So what I want to do is I want to introduce the concept of alkane nomenclature. And if we learn this, then we're going to be able to use this systematic method in order to name a bunch of other molecules later. All right? So a little bit of a history lesson really quick. Before 1919, chemists had no uniform way to name molecules. So they would basically just make up common names on the spot. That's what it was called. It was called a common name. All right? So literally some chemists would name molecules after their dog, after their ex-wife, after like something they saw like in the movies. I don't know. And it got really confusing because there were a ton of names that people started having to memorize as people started discovering more molecules. So 1919, the IUPAC convention gets together and they decide, hey, this is getting out of hand. This is getting crazy. We need to figure out a systematic method to name all these molecules. And that's when IUPAC nomenclature was born. So the way that it basically works is that there's 4 different things that we look at for IUPAC nomenclature. Here you'll see that what I'm giving you is an alcohol. Okay? So this is actually a little bit beyond the scope of what we're going to talk about for this first set. We're just going to talk about alkanes. But I'm just going to show you that what we do is we break up a big molecule into more manageable pieces. The first and most important thing that we always look at is the root. Okay, the root, this is also called, let me write it in black, this is also called the parent chain. Okay, it can be called the root chain or the parent chain. And that's usually just going to be, I'm going to go through these rules in a second, that's usually just going to be your longest chain. Okay? Alright, so as I said, I'm not going over the rules just yet, I'm just helping you guys see like the differences between, you know, these different parts of the name. So then what they said is, okay, well, not everything is on the root chain, though. There's other things coming off of it. So what they said is that anything that's coming off of it, they're going to call that a substituent. Okay? So a substituent is just a branch. Okay? So if you ever see that word, it just means there's a branch coming off the chain. So in this case, I have a carbon that is not on the black line, and it's just sticking out. So that means that would be a branch. Okay? But then, if we have branches, we need to know where is that branch. Because I can't just say there's one branch. Where is it? Is it at the end? Is it in the middle? So we're going to need locations for those branches. So another part of the name is the fact that I need to have number locations. I'm just going to put numbers in order to know where those branches are. Does that make sense so far? So basically, I have a main chain, I have things coming off of it, and then I have to say where those things are. Easy so far. It's kind of like giving someone directions, okay? You have to say, what's the street, what's the zip code, all that different stuff, all right? Then we have this one last thing called the modifier. The modifier is just basically the functional group, okay? I'm just going to put FG for functional group, and the functional group determines the actual, basically a suffix of the root, okay? So you're going to add a suffix at the end depending on what the functional group is, and that's going to tell you what kind of molecule your molecule is actually going to react as, okay? So like I said, this suffix has to do with the function of the molecule. Does that make sense? So like I said, this is beyond the scope of naming this molecule, is beyond the scope of what we're doing right now, but I just want to show you an example of everything, okay? Of all the different components.